Good evening, class. I wanted to record this and try and help some of the students. I realized that we hadn't really ever covered sessions quite as completely as I wanted to. There was kind of a gap between the blog post part 5 and part 6 where we kind of skipped over the actual setting up of sessions. But they're not that difficult, but I did want to actually take some time, go over them with you, make sure you're clear on that, because this assignment for this Sunday depends on building sessions. I'll go ahead and extend the due date on that for a few days, just to give you a chance to go back in and fix anything that you maybe didn't quite understand correctly. So let's go ahead and talk a little bit about sessions. And there are really three kinds of sessions that we can use: cookie sessions, in-memory sessions, and database sessions. We're going to start with cookie sessions because in a lot of ways those are the simplest. So I have kind of a very simple example app that we're going to be working with. It's an Express app, so we're pulling in our app.js, which is building an Express app. We have just two routes: say hello and log in. And the say hello is just printing out a snippet of HTML saying hello, embedding that. Now, obviously, this is not a complete web page, but it will work for our purposes, which is really just focusing on those sessions. And if I go ahead and run this, oops, I have some leftover statements in here that we don't need just yet. All right, let's try that again. Oh, yeah. And this one is not actually hooked up yet. If we look, it's pretty much an empty file. So right now, I'm just going to demo very quickly what this app does, which is just the say hello page. So if we go to the index page, we get our snippet of HTML, and it says hello. And let me pull that down so you can see that a little bit better. Okay. So jumping back to our code, let's get started talking about putting together a session. So if we come into login, right now all I have is just a mock user object that we're going to pretend we pulled out of our database. So this kind of reflects what our database structure might look like. We have a first name, a last name, an email field, and then the encrypted password, which just looks like a bunch of gibberish to us at this moment. And we're going to go ahead and declare a function, and we'll call this login with cookie session. And it's an endpoint, so we will have a request object and a response object. And what we want to do is create a session object, and we're going to store it in a cookie. So our session might look something like user, and maybe populate that with the user from our database. And then we would go ahead and put that into a cookie. And a cookie is basically just done with the response.set header. And it's a set cookie header that we're going to use. And then we just put the text of the cookie, whatever values we want. And it's usually a key value pair. So maybe session equals, and then we want to have some data describing the session. So what would that data be? Well, we have that session object. We'd like to maybe just use that whole object. Now, we need to put it into a string, and it's an object, which should immediately suggest to us serialize it with json.stringify, and that's going to turn it into a JSON string. And we probably also need to URL encode that because it's going in a cookie. So we can do that with code URI component. So we're going to stringify the session, then we're going to use URI encoding on that, and then we're going to store it in this cookie that we are sending down to the client. And then we can just go ahead and redirect the client. So I'm going to use a 302 and end. So that's going, we also need to set a location header if we're going to redirect. That's going to redirect us back to our say hello route when we visit this login route, and we're just going to go ahead and export this. Now, this is called login, the file, so when we export from it, that's really what we're going to pull it in from. And now I am exporting this math function. It really doesn't matter what it's named. The function is actually what gets exported, and we will assign it a value here. So we're going to assign it the name login, and then we can just go ahead and uncomment that route. And when we hit this, that should populate that cookie for us. So if we do this again, and we go to our box URL, same thing is going to work. If we go to the login route, and it helps if I spell encode URI component correctly. So it is encode with an O. And try that once more. And you can see we got redirected back to the hello. Now, in order to get that back out, we need to parse that cookie out of the request that we're getting. So basically what happens with the cookie is we send it with the set cookie header in a response from the server, and thereafter any more requests made by the browser to our particular application are going to include that cookie in a cookie header. And we can see that if we open up the network tab here and just refresh and take a look at our request. So if we go ahead and take a look at the request headers, so this is coming from our browser and going to the server. Notice there is a cookie header, and it has all this information in it. And the one we really care about is this session cookie right here. You can see it's got Bobby Test in their email, and it's URI encoded, so there's a lot of percent characters in there. But that is the cookie set plus a bunch of cookies that the Codio proxy server is setting, and there's a couple left in there from when I was doing some testing earlier. So we want that session, we want to pull that session back out of that cookie. And we could do that here in the say hello, but it really is a good job for middleware. So let's go ahead and add a new file here. And we can go ahead and we've seen parse cookie middleware before. We actually wrote a version of this way back with our favorites on the gallery. So when we added favorites to the gallery, but the functionality of a parse cookie is pretty straightforward. Function parse cookie. And since this is middleware, it's going to have the request and response object coming in, plus a next method or function that we can call when we're done with our processing. And we're going to start by adding a cookie object to this request. So before, this request doesn't have a cookie object. Here we have just now defined one. And we can do that because JavaScript is, again, dynamically typed. So we can add new properties to any object we want. We can define things on the fly, modify them on the fly. So it's a fairly powerful language from that perspective. So we just added something to our request object, just like we did when we parsed the body of a incoming post request or things like that. Now, the cookie that we're actually looking at is this string. We get this whole thing, and you can see it's multiple cookies. We want to pull those multiple cookies out and be able to look at them separately. So in order to do that, we're going to take that cookie string, and we get that from the request.headers, from that cookie header, which is just in there as request.headers.cookie. That will give us that exact string. Now we're going to take that string, and the first thing we're going to do is we want to split it up into the individual key value pairs. You can see that they are separated with semicolons. So we're going to split a cookie string on a semicolon, and we will call that var pair strings equals cookie string dot split. We're going to split on that semicolon. So that's going to give us an array of pair strings. And we will go ahead and iterate over that array. We'll do this the JavaScript way with a for each call function called on the array and passing in a function to invoke on each item in the array. So we'll call the individual items pair string singular, and inside of this iteration we're going to go ahead and break up that pair string. So let's call this pair equals pair string. And if we go back and look again at the cookies, or if we look at the definition of cookies, there's an equal sign between the key and the value. So we're going to split on that equal sign, and that will give us an array where the first entry is the key and the second entry is the value. So the first entry is the key, second entry is the value, so that's going to give us the key and value. And then we want to put that key and value pair into this object, which remember in JavaScript, objects are essentially dictionaries. So we can basically use this just like a C# dictionary where we say request.cookie and give it the key, set it equal to the value. And that's going to store in this request.cookie object that particular key value pair. And finally, when we get outside of this, we can just invoke next, which is going to take our modified request and the response object and just pass them down to the next middleware or endpoint in the pipeline. So this should actually go through parse@cookie, make it all available to us. So if we were to go back to our app, we could, for example, if we wanted in the login, say parse cookie here. Or if we think we're going to use it everywhere, we could actually just do app.use and say parse cookie. That's going to run this middleware with every route that we define. That's the same as if we put parse cookie in front of all of these routes that we define. So we'll go ahead and just leave it like that. And we need to bring in that middleware. And if you want to see what those cookies are, let's just go to our say hello, and just to show that it's there, console.log, and we will log request.cookies. So now we have added that. If I run this again, you should see it's parse cookies. That is an app. Parse cookies plural. I'm going to find, no, it was singular. It's in middleware, that's why. Well, first of all, let's rename this to be plural because we're actually parsing multiple cookies. Then in the app, we need to make sure that it says middleware directory. Now we should be able to start it. App.use requires a middleware function. That suggests to me that we're not giving it a function, which we're giving it whatever is exported from middleware parse cookies. Notice that we don't have an export statement, so we're actually exporting undefined, which is not a method. So module.exports equals parse cookie. So we'll export that middleware function, and that should make it happy. There we go, released on port 3000. So if I just revisit the page, notice it's dumping out undefined. So let's double check that we were adding that to the request. I think we want this to actually be plural. I think that's how I was using it in, say, hello, yep, request.cookies. Let's try that again. All right, so here you can see it dumped out. Here are our cookies. And you'll notice that a lot of these keys, there's actually some space right before the name. And actually, if we go back to looking at our header and the cookie here, notice that in our cookie coming in, we have after the semicolon a space in a lot of cases. Now, I'm not sure that space is always going to be there for every browser, but it's definitely there for Chrome. So one of the things we can do to kind of get around that is the key here. It's called trim on it. That will get rid of any leading and trailing white space and return the modified string. And I'll go ahead and do that with a value as well, because if there's leading, trailing white space, it's probably not intentional. So we'll go ahead and strip that, try it again, and see what our cookie now looks like. So we have now, notice these are no longer string keys. These are proper variable names, so we could actually use the dot syntax to access it, as well as the whatnot. And you can see here is our session, which is still URI encoded and still as JSON. So in order to get it out of that, we're going to have to add potentially another piece of middleware. Or we could wrap it into, instead of having a parse cookie, we could have retrieve session and kind of do the two steps together. But I kind of like keeping it split up, just in case. Oops, I'm not renaming that. I want to new file, just in case we want the other cookies for some reason. So here we will say load, and let's call this one cookie session, because this is for loading a cookie-based session specifically. Function load cookie session. It's middleware, so we get the request and the response objects, and of course that next function to call when we're done doing our work. And we're going to assume that the cookie was already parsed. That means that we should have session cookie equals request dot cookies dot, and it's the session that we're after. But like I said, because this does match the variable naming requirements in JavaScript, we can also access it with dot notation. And I think that's a little cleaner in this instance. So let's go ahead and grab cookies session. So we're getting the session entry out of that cookie array, or that cookie object. Now that is URI encoded. So to get it to just session JSON, we need to unencode, which is decode URI. So that'll turn it back into a regular string that's not URI encoded. We'll get rid of that percent encoding, and then we can go ahead and get our session by calling parse, json.parse on that session JSON. And finally, we can add that into our request. Let's attach it to the session. So again, another property of the request that did not exist before that we are now adding, and we'll just set this equal to session. So what we're doing, we're pulling that cookie, we're turning it back into a JavaScript object, we're attaching it to the session, and then we're pretty much done. So once we've done this, that will make sure that that cookie has, or that session cookie has now been turned back into a JavaScript object that we can access from that request object. And of course we need to do module.exports equals load cookie session. We'll save those changes, and if we go back to our app, we can load this as middleware. Say load cookie session equal require middleware load cookie session. Okay, and we want to do this after the parse cookie middleware, but before we hit our routes. So we'll say load cookie session. And of course, this has to be done after we've parsed the cookie because we need access to that cookie data. So let's go ahead and try that now. Well, actually, before we do that, let's go into our say hello, and we could just do request.session, and we'll see what that session looks like. So we'll stop this, And go ahead and reload. And we have an unexpected token percent in JSON at position 7. So that means probably our URL decoding is not quite working the way we want it to. So let's take a look at that load cookie. Remember, URI encoding means that it is percent encoding. So console.log here, session cookie. Oh, actually what we want is the JSON. So after we get this JSON, see what that looks like. I'll just reload this and user, and you can see our colons are still URI encoded for some reason, as is our @ symbol. We encoded with the URI component, which assumes it's not a full thing, but then we decoded with just decode URI. See if it makes a difference if we do it that way. It did, and you can see now our JSON string, and after we parse that JSON, we get back out the object that we put in. Now here's where things get a little bit important from a security standpoint, because you can see, or you should understand by now, this cookie gets stored on the client's machine. Depending on our client, that may be a public computer that they logged in from at the library or university or somewhere. It could be their personal machine that they keep very securely, but it could be a very public machine. And notice that we have that encrypted password just right there on the client's machine in a cookie, only URI encoded, so anybody could access it, see, oh, that's the encrypted password. I bet I could spend some time trying to break this. And honestly, with modern cryptographic techniques and a couple graphics cards set up in a server farm kind of deal, you can crack some passwords very quickly. Much faster than we really want people to. So we really just want to give them that opportunity. So we should never push that encrypted password out. So if we go back to our load cookie session, sorry, not load cookie session, but where we actually send that cookie session out, which is login with cookie session, we really want to trim down the session rather than just putting the user in there. We want to make sure that we've taken some steps to ensure that what we're sending doesn't have data we don't want to share. So if there's any information that needs to be kept more secure, go ahead and either just recreate the object, pull out the pieces you care about and leave the pieces that you don't, or we could delete the specific key. If I could spell delete, user.encrypted password should remove it from the set there, and we can try that. So if I reload this, oh no, I gotta log in again, so I want to replace that cookie. And now if we look at our session, notice that our user just has the first, last email. We've stripped out that encrypted password. So that is one approach to doing it. It's not, honestly, what I would say is probably the better approach would be when we do that login to actually redefine the user object to just have the things that we are willing to share. And the reason I say that is if we go back and we change this table at some point in the future, we're adding additional fields. Well, we may not have that delete line for those additional fields. We have to come back here and find the spot and add extra deletes. It's a lot better to go ahead and just make sure that we're only putting in what we want. And if we need extra fields, we'll figure that out. We'll come back to this point and have to add it back in. But I would always try to err on the side of being, if you're going to make a mistake, you're exposing less of your user's data rather than exposing more. So I would rather have the mistakes not expose our users as much. So this is actually a much better way of doing it, even though it's maybe not as convenient. So if we try this again, just going to go ahead and stop that, start it up again, and go look at run our login again. And if we come back, notice that after the login, we again have first, last, and email, but no encrypted password. So that's a much cleaner approach. Okay, now how would we actually use that? Say in our say hello. Well, remember it is added to this request.session object. So for example, we could just add here in the template string request.user or session.user.first and last. Actually, let's make a name. Session.user.first plus space request.session.user.last. All right, and we can take that out. So if we go ahead and run this now, what do you think is going to happen? We get hello Bobby test because we are logged in. Now, right now there's no way to log our user out, and this is something that really can't stand. So we also need to have the ability to log someone out. So we're going to add another endpoint, and we'll call this logout.js. And of course, because it is an endpoint, we have the request and response object. And what we're going to do is we're going to set that response header to have to set the cookie, and we're going to call this one session, and we're going to set it equal to nothing. So this basically overwrites the current session cookie that we have with an empty cookie. So there's no data in it after we do this. And then we'll do the redirect, which we do with response status code equal 302 and response dot set header location and slash and response dot end. Now it might be a good time to point out we've done this quite a lot. This is actually what we have to do if we're just using the HTTP server that's provided by Node. But because we've wrapped that in an Express application, Express actually adds a ton of helper methods, kind of convenience methods. One of those is response.redirect. If I could spell, which you might have noticed I started typing, and that does all three of these things for us. So if I were to just take that out, this would actually redirect us back to that. That only works if we actually are using Express. Let's go ahead and try that just so you can see that. And it is important to see if I restart the server, come back, notice I'm still logged in. Why am I still logged in? Because that cookie is stored on the client side in the browser. So it doesn't matter what happens on the server. Every time we talk to that server, we're going to pass that cookie forward. So obviously, that's one of the reasons we have to have a log out route, because if we're on a public machine, if that cookie's still there, the next person to log in or fire up that computer, go to this website is going to be logged in as the last user, and that's definitely not something we want. So we'll go ahead and do log out, and that will, well, if we have it hooked up, that will actually flush that session for us. So let's go into our app and add that endpoint. All right, so we're going to do app.get logout. All right, and we start that back up. And it looks like I forgot to export it. So if we go to logout.js, sure enough, module.exports equals logout. And fire that up again. And we can visit this route. And notice that that logs us out, but now we're hitting this unexpected error of JSON input. And that is happening in our middleware JSON.parse load cookie session. So if we look at load cookie session, get in here and we decode this, logging it, and then we go ahead and try to parse it. Now, since we're logging it, let's go ahead and take a look at the log. And first time there, we got our object. Next time through, that's logged right here. And notice that it doesn't seem like there's anything. Remember, we set it to nothing. It's exactly what we got, an empty string. And calling JSON.parse on an empty string, not going to work. So there's a couple different ways we could handle this. We could test to make sure that the session JSON actually exists. So if session JSON does not equal the empty string or null or something like that. But because there's other things that can go wrong, like if somebody has tampered with the session cookie, it's no longer valid JSON. It's better to put this within a try catch so that if that's a problem, we just won't assign the session object. And we can go ahead and console.error that so that we have a record of it. And basically, we will only set the session if this parsing succeeds. Otherwise, we'll just jump to the next. Decode URI component, I don't think we'll ever have the same problem because it just replaces some characters. So we can leave that outside the try catch. You could also put it inside the try catch if you felt strongly about it. And now notice we cannot read property user of undefined in our say hello. Don't have a logged in user, which means we don't have a session. And if we go back to our say hello, notice that we are using the session.user. So if that session doesn't exist, this can't be done. So an easy way of checking is just to see if someone's logged in. We could say const logged in equals and we just want to know if this is a true value. So this is an object or null. We want it to be a Boolean. We can treat it as a Boolean, like we can drop that right into an if statement because existing objects are truthy in JavaScript. We can treat it as true, but that's maybe not the most satisfying, is actually seeing it as a Boolean. So we can just go ahead and Boolean and it with true. So if this is a falsy, it's going to be false, and if it's true, true and true is going to be true. Or we could word it with false. I mean, there's lots of different ways we could do that. And this is not strictly speaking necessary, but it can be nice to have it in a variable that you recognize. And we could just go ahead and do a check. If we're logged in, go ahead and make the name be this. And if we're not, we'll make the name be the empty string. If you haven't seen this before, this is the ternary operator. This is a logic test. If it's true, the value is assigned this first half before the colon. If it's false, it's assigned the second half. So this basically says if we're logged in, set the name to be the user's logged in user's name. Otherwise, set it to be an empty string. All right, now that we've done that, we should be able to show our main page. Hello, notice it doesn't have a name. If we go ahead and follow our login route, That creates our session. Now we're logged in, and if we log back out, we're logged back out. So this basically shows you a couple different things about working with those cookie sessions, that we can go ahead and, not there, we can basically test to see if we're logged in by just seeing if that session actually exists. If it exists, we're logged in. If it doesn't, we're not logged in. So that's a cookie session. It's the simplest because we just dump everything in the cookie, we pull everything out of the cookie, easy peasy. The downside of the session cookie is we're putting all the session data on the client's machine, which means it's inherently insecure. It's potentially accessible by other people, other parties that might have access to that machine for whatever reason. And it's just something that a lot of, especially if you're doing a lot of sensitive information, credit card info, stuff like that, you don't really want to store that in a session. You can make it slightly more secure by encrypting the session before you send it down. So that's just one more step. So like when we do a login, we encoded and stringified, we could do one step further and encrypt that with some kind of cryptographic algorithm and decrypt it when we parse the cookie back out. That makes it stronger, but it's still putting that data there where potentially somebody could get a hold of it and work on it and eventually potentially decrypt it. So the other kinds of sessions are really meant to help deal with that issue. Plus, there's a limit on how much data you can put in a cookie. There's not a hard limit in the specification. The guidelines say probably not more than 256 kilobytes. That was written a long time ago. Most of the browsers can handle probably a bit more data than that if they want to, but it's up to the browser manufacturer as to how much data they actually want to support in a cookie. So if you need to store a lot of data for the user session, that probably isn't going to fit in a cookie, or it's probably not a good idea to put in a cookie. Besides the fact that that cookie will get sent back and forth all the time between the client and server, which means you're consuming extra bandwidth. You don't really need to. So let's talk about the second kind of session, which is an in-memory session. And let's go ahead and add to our source a new class. If you look at the blog part 6, we have a session object that follows these ideas. I'm going to call this in-memory session here, because I'm going to talk about database sessions as well. So just to keep these separated logically, we'll have a spot for the in-memory session. And what we're going to do here is we're going to have a session object, or actually sessions, plural. And it's just going to be a JavaScript object. This is a dictionary, or at least we can treat it like one. It works very exactly like a C# dictionary, but unlike a C# dictionary, we can put whatever we want into it. So we can have key values where the values are a mixture of arrays and integers and functions and whatever. That's really all an object in JavaScript is. So we're going to treat it, in this case, as a dictionary of session data. So for each user, we'll have a key that corresponds to that user, and then we'll have their data. And the first question is, what should we use for that user key? And probably the obvious answer would be, well, we've got a user in a database table, they've got a primary key, let's just use the primary key. That makes a lot of sense. But there's a problem with that. If we look at primary keys, usually they are generated numbers that are counting up. So the very first entry is going to be entry 1. Your ID is going to be 1. Second user is going to be entry 2. Third user is going to be entry 3. So your IDs are very guessable, very predictable. If you sign up for the site and your user ID is 156, it tells you there's probably 155 other users that you know what their ID is. Not specific to any specific user, but if you go in and manipulate, because we're going to have to store that ID somewhere, and we're going to store it in a cookie, you manipulate that cookie, change that ID number by 1, suddenly you're logged in as somebody else. And if you do that enough times, you can find somebody who maybe has admin privileges or information you care about. So as an adversary, you seeing somebody use the primary key out of a database as the key is a really nice thing. For us as developers, it's a really bad thing. We don't want malicious people being able to figure out how to hack our sessions and turn somebody else's their session into somebody else's session. So instead, we're going to use a UUID, a universally unique identifier. And these are just long strings of cryptographically generated bits. And we're not going to try to write one on our own. We're going to use an existing library. And the library I'm going to use for this is going to be... hold on just a sec. Got to look it up here. My notes. UUID. Well, that's easy enough. So if we go to terminal, we're going to stop this, clear this so it's a little more legible, and we will do npm install UUID. All right, so we have just added that to our project, and I'm going to go back to in-memory session, and we're going to add const v1 UUID v1. So there are different versions of the UUID generation algorithm that are used for different purposes. We're going to use version 1. So we're going to extract it out of the UUID library. And this is the syntax that they use. What basically require UUID, like a lot of these, will give you a whatever was exported. In this case, an object was exported that contained a whole lot of methods, a function for each version of UUID, and we're just going to extract one, and we're going to assign it to this v1 variable, just so it's easy to this is a special operator that unpacks that object and assigns it. So this UUID v1 is what we're going to actually end up using. So we are going to add a function, generate UUID, which generates this UUID for us. We're going to use this every time we create a new session key. And so we'll get var UUID, so this is our identifier, equals UUID v1, and part of the reason we're using version 1 is it doesn't have any arguments, so that's just going to generate a hopefully unique identifier. It should be. It's one of these cryptographic algorithms where it is mathematically improbable that it will create the same key, but I like to be extra sure just because I'm super cautious about these things. So we'll go ahead and say while session plural UUID, and notice we're just plugging that in as a key to the sessions object. Remember, we said that's a dictionary, so this is pulling out the value for that key. If it's defined, so if you are using that key already, this value will be a session object, which in JavaScript objects are truthy, so this will evaluate to true. So if we've already used that key, this will tell us that, oh, we've already used that key, and then we'll just trigger the generation again. UUID equals UUID v1. So we'll generate a new key and try the new one. That's what it does. On the other hand, if we haven't used that key, then the value here will be undefined, which in JavaScript is falsy. So that will evaluate to false, and we'll just basically skip over this line 7. We won't do anything else. So we'll generate one UUID. It will be unique. We'll move on. That should happen every time. Mathematically speaking, we should never have an overlap in keys. But it is very, 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 very faintly possible. This just keeps us from having that problem. And it's not that much extra, one check to see if it actually exists. Not that much extra code. I don't see any reason not to do that. Okay, and that will give us our UUID. And let's go ahead and have a function to create a session. And we're going to take just some session data. And if you go look at the one that's in blog part 6, there's a lot more that we're doing in there that we really don't have to do. So I'm going to step it back and we're just going to drop the data in. So here, the data is going to contain we're going to create a session object in the sessions table using one of these UIDs that we've generated. So let's call it session ID, SID equals generate UUID. That gives us our unique identifier. And then we're going to set in the sessions table an object, which honestly what we want to put in there is just data. So I'm going to do this very simply. And then we're going to return that SID, the session ID, so that we can use that as right here. So you know what? I'm going to move this. So rather than doing this as a library, I'm just going to do this as our endpoint. So this stuff I'm going to move into our load, our login. So we need the UUID here. And I'm going to go ahead and have we're going to move this in here. So this could be declared in another library like we did in the other example, but I'm just going to make this super simple. So sessions, so we have this function login with cookies. We're going to create another one, function login with in memory session. That way I have access to the response, the request and response object, because I'm going to take this out of here and move that into there. So log in. So we're generating our SID. I'm going to delete that in memory session here. Okay, so login with memory session, the request response object. The first thing we're going to do, and again, we'd want to go ahead and make sure that the user was logged in correctly so that they have the right username and password, they're the person we think they are. This is going to go kind of in that, okay, they are the right person. Now we're ready to create the session. We're kind of skipping over that. We're assuming whoever hits that login is the right person. In fact, we're assuming they're this person, which we clearly are not pulling out of the database, but we should be in a real function. So this is just, again, just focused on the session implementation. So you still have to do the login checks with your bcrypt algorithm and all of that. So what we're going to do in here, we just get that session ID, we create that session, we're going to put the data in the session. That session, we'll just make it look just like the session here. So all we're putting for this particular instance is the user's information into that session. And just assign that to the session. Now the question is, when we come back, how do we know what session belonged to this user? Remember, no state in HTTP. The only way we get state is by using those cookies. And that's exactly what we're going to do. We have to add it to a cookie. Just like we did down here, we'll set a header or set cookie. And then let's call this SID for session ID. And then we'll go ahead and put into that our SID, whatever that value is. So now, instead of storing all the session data on the client, all we're storing is that session ID. And yeah, do that. Yeah. So we create our session, we store it in this dictionary. Now you also might be wondering, well, every time I require, aren't I getting a new copy of this module? And this is actually taking advantage of the way that Node uses what are called CommonJS modules, and how it actually works in the CommonJS pattern is the first time we require it, we actually execute this code and return whatever is exported. The next time we require that same file, we actually just get a cached version, so whatever we loaded the first time. So this is essentially modules you can create kind of as a singleton by returning an object. It's always the same object. So this sessions object here will be the same across every time we require this login.js, which is actually kind of pretty handy because we can basically treat it as a global singleton that is nonetheless wrapped inside of a module and protected data hidden, if you will, because we can only access it from within this module. So that's actually pretty nice. Here we're going to change the login from cookie session. We're just going to shift over. So we're not going to use the cookie sessions now. We're going to use in-memory session with in-memory session. So we're swapping our implementation. That also means that our middleware, how we're loading the session, is going to change. So if we go back to our middleware, we have load cookie session. Let's have load and I got a little too clever and I bit myself in the bum, because in order to load that, we have to have access to this sessions object, which we don't have here. So let's back up one. I got a little too clever. We will go ahead and put that library back. A new file in memory session store. I'm going to call it session store. In memory session store. So we're going to pull that back out of login. So this library and this dictionary and the generate ID. Yeah, so, and I didn't pull that one across, I just deleted that anyway. So we need that UUID anyway. So so this is called session store. It's understood to be in memory session store. So I need to rewrite that function, generate UUID. And just going to copy my code from my notes because I don't want to rewrite that. I already wrote it once. And I'll just throw the semicolon on there just to be clear. If you haven't realized by now, semicolons are not required at the end of lines in JavaScript. They're optional. I put them in because you guys are used to seeing them, but it will run just fine without them. Okay, and then we need function create session, and I'm going to pass in the session data. Okay, so here we would go ahead and get our UID, our session ID from generate UUID. And I've been doing too much C# lately, so I'm following naming conventions from C#. Generate that SID, sessions, SID, set that equal to the incoming data, whatever that is, and we don't care. We're going to return that session ID. Okay, we're going to export an object in this case, and we're going to export create session as one of the things that the session store can do. So now in our login, we're going to rewrite this a little bit to use that session store. And we are in the middleware, so we need to go up one level to get to the session store file. Remember, requires are relative to the location of the file within the file structure of the project. So from the login, which is an endpoint, we have to go up one level to the source directory to get to session store. Okay, now login with in-memory session. We now can just generate a session with our creator var SID is going to be returned from that create session. So session store dot create session, and then we want to pass in our session data. So this session object that we've paired up here, which is the same as we did in the other session example, and then we do have to take this session ID and set it as a cookie so that it will be there when we want to load our in-memory session. So this works very similar to the load cookie session. We're going to get the session cookie back out. So here, function load in memory session. And this is middleware, so we do need to request the response in the next. And we're going to get that session cookie out of request.cookies.session. Remember, that's parsed with this parse cookies, so we get that out. And it's not session we're after, it's the SID. So let's go ahead and change this to SID as well. And this should be a string, which means we need it as, a string. Actually, that's perfect. So that should come out as a string. We didn't URI encode it, so we don't need to URI decode it. In fact, we're just storing it as whatever that string was. So we don't have to do any kind of special parsing, no work with JSON. All we're doing is grabbing that session ID, and then we can get that from our session store. So we need to write another method in here, function SID. So this is going to retrieve the session using that session ID. So we're going to just return sessions SID. Because remember, it's a dictionary. We just need to look it up by the key. We can return that value. And now they are modifying the session that's stored in memory. Now, if you look at the other example, we actually created a clone by stringifying and then parsing it, so there was completely a separate object. In this case, we're actually just passing a reference to the sessions object. So if we modify this, that is now a change that is there for the session, for the rest of the life of the session. And that, in some cases, is the functionality you want. In other cases, may not be, so you can pick and choose whichever one makes the most sense for your application. But this is a very straightforward one, and allows you to modify the session without having to do an update or anything like that. So it's pretty convenient. Okay, so get session. We need to export this. That's going to spit our session back out. In order to take advantage of this, we need to bring in this library, const session store equals require session store. And again, this is actually in middleware, so we do need to go up a level to get to the session store. We're going to load that up. So now we can get our session out of that session store by passing in that session ID that we extracted. Now, what happens if we request an SID that doesn't exist in the database, or doesn't exist in the session store? We're going to get an undefined value back out. So that's pretty much what we want. And actually, we want to assign this to request.session. So the same way we did with the load cookie session, we attach it at request.session. So load cookie session in-memory session. So we attach it, and once we've done that, we move on. Pretty straightforward. Grab it out of that dictionary, display it. If it's not logged in, it shouldn't cause a problem. So now we're going to go to our app. So we've already switched our login process to match what we're doing there. We're going to switch from using load cookie session to load in memory session. And I'm going to actually swap which one we're actually using because we don't want to use both. They're both setting a session variable on the request object, so one would just overwrite the other, and I don't want that confusion. And finally, we want to go back and rewrite our logout so that we are logging out and we do that by just flushing that SID. Let's see, did I capitalize it? In the login. Nope. So we just want it to match. That will flush our SID. So now when we log out, should just flush that session. Actually, we want to do one more thing. So const session store equals require up one level session store. We also want to flush the session. From the session store so that it's not taking up memory, because once they've logged out, the session's done. And so we'll add a delete session here. And you saw me use delete earlier. That will remove that particular entry from that sessions object, so it's no longer taking up memory. And of course, we have to export this. Okay. So we have 3 functions we're exporting, and we can use those where we're using them. Let's go ahead and see if I did everything right or if we're going to have some problems here. App.use requires a middleware function. I bet you our load in memory session is not being exported. Try that again. And we're listening. Hello. Get the login route. Hello, Bobby test. We're logged in. Get the logout route. Reference error. SID is not defined. Logout line 5. Out. All right, request. So this is interesting. How do we get that SID? Yeah, we get it from the cookie the same way we did before. So we do request.cookie.sid. That should do it. And there's a chance that that will be undefined. So we really need to deal with that. That's not actually what I was complaining about. What I was complaining about is in the logout. Request.cookies, that's why. Let's try that again. think the delete should work even if it's undefined. Okay, so if we log in, hello Bobby test, log out, back to hello. Let's log back in. We're logged in. We're going to stop this, restart the server, and reload the front page. Notice our session is gone. This is one of the things about in-memory sessions, because they are stored in a variable in memory, in volatile memory. If we shut down our server, bring it back up, every session that was running is gone. Now, in a lot of cases, this may not be that big of a deal because sessions are really fleeting anyway. We don't want sessions to stick around a long time, but that is the downside. If we put it in a database, then it's not gone. And that's because the ID we're storing, the session ID, is still in the cookie. So what's happening here is when we come in and we try to get session, we're passing in a real SID that we pulled out a cookie, but the sessions object doesn't have that particular session ID in it, so you get back undefined. So it's basically not a session. So let's do a database session. So we basically set up our session the same way. And then instead of going to the session store, we would create an entry in a table in the database, a sessions table. So we'd have to require a database. So assuming we set it up the same way we have in the past, we'd say db.prepare, and we would insert into sessions and whatever our columns that we're going to use. So there's a couple different ways we can do this. We could actually hard code in the database, have a column for first name, last name, and all of that. Or we could have a column that we put data into. And what we do is stringify this into a JSON object. So var JSON equals session the and probably also have the user as a foreign key. Which, remember, we've got our user, we pulled them out of the database. Our understanding would be if they came out of the database, we technically have an ID parameter, base 34. So, and then run with user.id for the user ID and JSON. It's session JSON. So we put that JSON string in there, and that should now be in our database. And we can go ahead. I told you not to do this, but we'll go ahead and do it here. Info. That's like last created row. You can look it up in last created row, something like that. comes back with that info object from Better SQLite 3. I'll look it up really quick. Go to the API documentation for Better SQLite 3. There. Run. Get back an info object. The info has last inserted row ID. And it's probably also a good idea to make sure that the changes were made. So info.changes is the number of rows that changed. That should be 1 if we inserted a new row. So if we did that, we can go ahead and just do it this way. Does not equal 1. And then we can send an error. And you probably want to do that using your own kind of way of doing your error reporting, but basically send a server error code because something went wrong. And if there was one change, then we've inserted our row, so we can grab our session ID, or we'll go ahead and call it SID again. And we can go ahead and basically do the same thing we did with our SID with the in-memory session. The difference is now we're storing it. Okay, and if we want to do a slightly more involved version, rather than inserting their session right off the bat, we could check to see if there is an active session that has this user's ID in it, which might have been an abandoned session that they're picking back up. This also means if you do it that way, they can move from device to device and get back to their session on a completely different device because they logged in as the same person. So you can create sessions that move from device to device this way, which you really can't do with the in-memory session, at least not as easily. So those are some things to keep in mind. But basically, the rest of it's pretty much the same except for loading that database session. Load. You would then acquire your DB, which is up one level from here. Function request response and the next. And this is going to look very similar to the load in memory session, where we're going to pull that SID from our cookie. And then we're going to go to our database. Where ID equals, and then we put our SID in there. And where session, this is actually get SID. So that should return the session object, or null if that's not in the database. So we can just go ahead and actually put that right on our request object. So set the request session to that. Next. So if the session exists, we've loaded it. If it doesn't exist, fine. Now, obviously you have to create a sessions table that has a data text column that you can put that JSON into. Oh, speaking of, that is JSON. So we need to actually parse it. If that actually exists, then we can say request.session equals JSON.parse. That string. And we'll go ahead and surround this in a try catch. And if we want, we can console.error, that error, if it happens, to let us know that we had an invalid cookie and what it looked like. If you're working at a big firm, they may have security guys who will actually want to look at those logs and use those to try to track kind of malicious efforts to break into the system. So there may be some additional work you want to do with that error. But for our purposes, we can just, if it's not proper JSON, then ignore that session. We'll create another one. All right, so that's kind of the core ideas. Now, going back to security, we do want to, no matter which one of these we're using, we don't want the session to last super long in most cases, because again, if that session ID is valid, other people can eventually get a hold of it and use it. So we really want these sessions to flush with relative frequency. So with the database sessions, we would normally keep track of a date of last activity in this table as well, and then we'd have some kind of automated script that's going through every hour or so, and if it's been inactive long enough, flush it. It's gone. Get rid of it. The same with the session store. What we can do, and this is actually in your example, we have an expire sessions method that just goes through all the sessions, checks to see if it's expired, and if it is, we would get rid of it. There's an expired method in that example as well that basically checks to see if the current date minus a timestamp that's stored in the session is greater than the maximum duration. And if that's true, we delete the session and mark it as expired. In order to do that, we have to have that max duration variable. So let's just go ahead and declare it as a constant up at the top here. So in this case, 3 minutes of inactivity. That's not a very long time. I did it that way because it's a demonstration. Usually you'd go a bit longer. And then also maybe an interval for how often we want to clear those, like every hour. So milliseconds, 1,000 milliseconds per second times 60 seconds to a minute times 60 seconds to an hour. That's where those numbers are coming in. And then we just create a my timeout. Oh, there is not one. So we go ahead and set that up. When we create the session, we would go ahead and add to the data the timestamp equals date.now will give us the current timestamp, and then we would go ahead and check before we get the session and that will actually delete it if it is expired. So then when we return it, we're returning undefined, so that would protect us there before the session gets used. But we also might want to clear them out periodically because that frees up memory, so expired sessions really we don't need to hold on to. So we could do a set timeout, and we're going to call the expire sessions. Remember, set timeout, or not timeout, set interval. It's like set timeout, but it keeps occurring at a set interval. So it's going to call the function expire sessions, and we're going to do it at this expiration interval. So every hour we will fire up Expire Sessions. I'm just going to iterate over all the SIDs in the sessions variable and check to see if it's expired. And if it is, as a side effect, it will be deleted. In fact, we could just have called that check if session is expired or something. We didn't have to return a Boolean because we're not returning the Boolean or using the Boolean we return anywhere. But it's just a basic idea that we want to flush those. The other thing we can do is our cookies can have an expiration time. And you can go back and look at the cookie lesson, Fun with Cookies exercise. We played with expirations there. That will go ahead and get rid of those at automatically. The browser will get rid of them, but again, it's happening client side, which means it's not inherently as secure as if we're doing it on our end on the server. And since I haven't actually switched to the database sessions, we just wrote the code to support it. If I go ahead and start this and we go log in, and if I immediately reload that page, the session's still good. If I let it go for the, what did we say? It was 3 minutes we were going to let it, or 3 seconds. It was not very long. 3 minutes. I don't know if you want to sit here and let me talk for 3 minutes. Let's just see if we're still logged in. Still are. So let's bump that time just for demo purposes. Session store. Let's session max duration. Let's take out the 3 and 60. So 1,000, that would be 1 second. So now if we fire this up and we go log in, and after a second, just 1 second, we come back in, our session is gone. It's been expired because we were inactive for too long of a period. So that's some of the ways that we can help secure some of these sessions, make sure they're more secure. So again, talking about security, cookie sessions, not the greatest in terms of security. They're quick, they're easy, but you're putting all the information out there on the client, and you can't store a huge amount of information there. In-memory sessions are pretty slick. Where they kind of fall down is if you are doing multiple servers and you got a load balancer in front of them, so you're doing the horizontal scaling idea. You can't use a variable in the actual server because you got multiple instances of the server. They each have their own variable, their own dictionary, and they're not lining up with one another. You can still use an in-memory store, but you take it out of the server and that session store becomes its own program that you have to talk to, just like with a database. But it can be using volatile memory, so it sticks around, and because its only job is to update session data, you can get away with doing it that way. That said, you have to have an update method to update the session because the session you get back from it is not the one it's storing, it's just the raw data. So it's slightly more complex to do horizontal scaling. With the database, you already have the database in horizontal scaling, one database instance that all those programs are using. So the database session store works just fine with horizontal scaling without any extra tweaks or outside libraries other than the database that you're already using. So that's kind of some of the strengths and drawbacks. The in-memory session store, of course, flushes if you kill the server as well, unless you have, again, running on an external session store, in-memory store. And there are some very fast memory stores that you can take advantage of. But the database one will stick around as well. All right, hopefully that gives you a much better idea of what to do with sessions. I'll go ahead and extend the deadline on this milestone 5 a little, milestone 6. I think it's 6. The one that was due this week, I'll extend it a couple days to give you a chance to put those into play if you're having trouble with that. Also, we have reached the end of the prepared materials that from last semester. So we're actually a bit ahead of where the class was last year, which is awesome. but that means I am putting together materials for the last couple weeks. So we're going to shift gears a little bit. I thought maybe it'd be good to see some other frameworks. So we're going to use Microsoft's ASP.NET MVC platform, so some C Sharp, and then I'm also putting together a React example that we're going to work through of building a web socket-based chat system. So something kind of like a Discord, a very stripped down version, but the same ideas. And so that will be coming. I probably won't have it out. Probably maybe Monday night. We'll see. Maybe Monday, maybe Tuesday. So take this extra time to work on the milestone. We will still continue to have milestone assignments. We're just going to keep adding a little bit of functionality using what you've already learned. So it's really more of a refinement at this point than adding new ideas after the authentication. So that's kind of your update. And so good luck, and let me know if you have questions.